Alright, so in the last video, we solved the part 1 of the problem, and now we will deal with the part 2 and part 3 of the problem. So in the last part, we calculated the value of a, and now in this part, we will actually sketch the graph of wave function at the x at the time t equals to 0 with the x-axis as a function of x, and I will find out where the particle is most likely to be at t equal to 0. Right, so first of all, let me draw the graph. So what I know is that if my particle is not in the region from 0 to b, then it is 0, then my wave function is 0, right? So it will just simply touch the x-axis if it's not, right? So here it is, it is touching the x-axis, right? It is touching the x-axis. Now as it moves from 0 to a, so it will increase directly proportional to x, and here it goes, right? And here it goes, and let's say this point be a, and this point be here be the small a, right? And now what will happen is that since the function, we can see from the function that it will decrease further in the interval from a to b, so it will decrease linearly and will touch the ground. I'm sorry for this, let me just correct it a bit. Let it be in an approximation side. So here it will be the point b, where, and from b onwards it will again be, the wave function will again be 0, right? So this is how my wave function will look like. And since we can see that this peak is attained at point at this is attained at x equals to a, so my particle is most likely to be at x equals to a. Alright, so in the last part, we talked about uh, sketching of the function and where the particle is most likely to be found, right? So in this part, I will talk about the probability of finding the particle on left of a. It means that I will check in this region that what is the probability of finding the particle in this region, right? So let's get started, right? So how to calculate the probability? So sorry, let me change the pen, sorry. So yes, so I know the probability of finding the particle. If E is the event of finding the particle, then probability of finding the particle will be integral from 0 to a wave function square dot dx, right? So let's put it here, which is equals to, so yeah, so from 0 to a, so it would be integral 0 to a squared x squared on a squared dot dx, right? So let me take it outside, constants outside, a squared upon a squared integral 0 to a x cubed by 3, so it will be a squared upon 3 a squared times a cube, so a squared got cancelled and it is left with a squared a upon 3, right? So in the previous part we have already solved that a equals to root of 3 upon b, right? So let's use it here, right? So what my probability of finding the particle will come out to be 3 upon b multiplied by a upon 3, so it will be simply a upon b. So to check the limiting case for if it is given that if a equals to b, right? So the probability or what the probability will be, it applies here, then the probability will be simply 1, right? For case 2, if b equals to 2a, then probability of finding the particle will be a upon 2a, that would be 1 upon 2, right? So with this, my problem is ends here.